Algebra 2 Honors, Lesson 9-4, Rational Expressions. Alright, let's get to the first example. Alright, the first thing, alright, I'm going to do is show you what not to do, okay? So first of all, this is a rational expression right here. Alright, basically it's a trinomial or binomial, alright, dividing each other. Now when you're asked to simplify, alright, what you should not do or what you cannot do is you can't just start canceling stuff that looks to be exactly the same. Meaning, oh, x squared and x squared, these are the same, and then you cancel them. You cannot do that because right now these plus signs, or it could be a minus sign, they kind of link all this together. Right now you have to think of this as one whole term. So you cannot just cancel a part of it like this. That's wrong. Okay? What you need to do is you need to factor everything. Alright, so going back to chapter 5, you follow all the steps for factoring. Alright, so remember you would look for a GCF. Alright, this has no GCF here. So then you would do the x. Right? So you would do the x. A times C is 25. B value is 10. So that'll give you 5 and 5. Alright, the A value is 1, so divide by A, which is 1. So your factors are x plus 5 and x plus 5 divided by, and then you do the same thing for the bottom, look for GCF. Alright, there's no GCF here, so let me do the x. A times C is 20, B value is 9, so it looks like 4 times 5. Alright, these multiply to give you this, add up to give you this, divide by the A value, which is 1. So on the bottom you have x plus 4, x plus 5. Now that you have factored everything, right? If there are any terms that are the same, you can cancel them. You know, there's this right here. This is one term here. This is the x plus 5. This is another term. It's another x plus 5. So what you've done is when you've factored, you've separated, all right, these into different terms. Right? Now these terms are the same, so it's okay to just cancel this out. Okay? Because these are all separated now. Right? So then you're left with x plus 5 over x plus 4. Okay, so this would be your answer. Now next thing, they ask you for restrictions. And if you recall from chapter 1, I know it's been a while, but chapter 1, restrictions, basically we can't divide by 0, right? So anything that makes 0 in the denominator, in the bottom, you can't have that. So what are the values that x cannot be, right? Those are your restrictions. So you notice here, when is this going to be 0? If x is negative 4, right? Pretend x is negative 4, right? That'll give you 0, right? So that'll give you negative 4, right? Why can't x be negative 4? Because if you plug a negative 4 in here, that makes 0 in the bottom. Okay? And then also, when you're checking for restrictions, you have to check your answer, or the denominator, right, in your answer, and anywhere in the problem, or any part of the problem, all right, you cannot have 0 anywhere in the denominator in any part of the problem. So over here, even though you had canceled out the x plus 5, right, even though these eventually canceled out, you still need to consider it as part of your, or as part of the restrictions when you're looking for restrictions. So this x plus 5, when is this going to be 0? Right, well, when x is negative 5. So x can also be, right, x cannot be negative 5. Okay, so why are these your restrictions? Because if you plug in negative 4 here, what happens on the bottom here? It makes 0. Alright, negative 5, if you plug in negative 5 here, right, what happens? It's going to make 0 right here, right? So when you're looking for restrictions, right, you want to make sure, right, whatever results in a 0 in the denominator, right, you can't have that. You have to say x is not equal to whatever those values are. That's how you find restrictions. Okay. Let's take a look at the next example. So right here, we need to simplify this. Right? Now you notice these are all kind of separate terms right now. There's no plus or minus signs linking all these. Right? So make sure you follow the order of our operations, our PEMDAS. So the first thing you need to simplify, or first thing I would simplify, is this exponent out here. Okay, I will simplify this exponent out here. So the top stays the same. So the top is 2a squared b to the third c. And then the bottom, if you simplify this exponent, right, that would be 4a to the negative 2 b squared c to the fourth. Now that you simplify this exponent, or any negative exponents, you want to make positive. So you notice you have a negative exponent here. You want to make it positive, so you got to take the base of the exponent. All right, if it's on the bottom, you're going to move it to the top. So basically, you're moving two a's to the top, and then that'll make this positive. Okay. Everything else you don't need to, or anything else you don't need to move, because all these exponents are positive. So only this negative exponent you need to make it positive. All right, in order to do that, you've got to move the base. All right, if it's in the denominator, move it to the top. If it's in the top, you move it to the bottom. All right, so you're going to end up with, let's see, 2a to the fourth, b to the third, c. On the bottom, you have 4b squared, c to the fourth. All right, so now that everything's kind of positive, all right, all the exponents are positive, now you want to cancel out, right, terms and reduce. Alright, you notice all these are multiplying with each other, so that basically means they're separate terms. So you reduce the 2 and the 4, alright, kind of like normal fractions. Alright, all the a's are on top, there's 3 b's on top, 1 and 2 in the bottom. Just get rid of 2 b's, get rid of 2 from here, so you'll be left with 1. Get rid of the c right here, so you'll be left with 3 c's on the bottom. So on top, what are you left with? A to the fourth, b, and on the bottom you're left with 2, right, c to the third. So this will be your answer here. And if they don't ask you for restrictions, then don't worry about it. Alright, so this will be your final answer right here. Notice you can't simplify or reduce anything else. Okay. Multiplying rational expressions. So for multiplying rational expressions here, what we're doing is, we're going to take these two problems and we're going to multiply them. Right? So I'm just put this big red dot here. So that means multiply. So you follow the steps. Remember, you can't just start canceling stuff right now because you need to factor first. So we need to factor this right here. Alright, so we need to factor this right here. So is there a GCF? Nope. Let me do the x. So then 2 times 3 is 6. We're trying to get 7. So what are the terms that multiply to give you 6, add up to give you 7? 6 and 1. Alright, what's the a value? The a value is 2. So this reduces, right? 1, 3. So then we're going to end up with, right here, x plus 3, 2x plus 1. And then this, you can't factor that in anymore, so that's nice. Over here, you should recognize this is a difference of squares, right? No GCF, it's a difference of squares. X plus 4. X minus 4. And then down here, you would do the x again. There's no GCF, just do the x. Basically, you're going to end up with x plus 3, x plus 5. Alright, you do the x. So now that when you're multiplying, you could look to cancel. Now when you're canceling, you could cancel either across in an x, like this, alright, kind of in an x, across, or top with bottom. You cannot cancel side to side, okay? So in an x, or top with bottom. Top and bottom's okay, or in an x, not side to side. Alright, so it looks like x minus 4 and x minus 4, these are the same. X plus 3, those are the same. So it looks like we are left with 2x plus 1 on top, x plus 4, and on the bottom we're left with an x plus 5. Alright, so this will be your final answer right here. Now once again, we're asked for restrictions, right? So we have to think, alright, remember restrictions, we cannot have 0 in the bottom. So first let's start with our answer. So we have this x plus 5 here. So what value of x would make this 0? Well, x cannot be negative 5. If you put negative 5 here, negative 5 plus 5 is 0. So x cannot be negative 5. And then you have to remember, I told you, even if terms cancel, you have to consider them when you're looking for restrictions. Over here, there's x minus 4. So when is this going to be 0? If x is 4. Right? When is this going to be 0 right here? If x is negative 3. Okay, so anything, remember, we're only checking the denominators. We don't care about the top, only the bottom of the fractions, because you can't divide by 0. Right? Dividing rational expressions. Now when you're dividing, right, so let me just put a division sign here, just so we know that we're dividing. So if you're dividing rational expressions, right, basically you guys have to remember the rule. Dividing is the same thing as multiplying by the reciprocal. So what you can do is, since we're dividing here, right, you're going to change this to multiplication. Right, so instead of division, the same thing as multiplying by the reciprocal. So the one on the right, that's the one that you flip. So whatever's on the bottom goes to the top. And this one's a nice example because they factored everything out for us already. And whatever's on the top goes to the bottom. So the right, the fraction on the right, that's the one that you flip. And over here, the left stays the same. 4 minus x over 3x plus 2, x minus 2. And then now you want to look for terms that are the same, right, so that you can cancel them. Now everything's already factored out, so this was a nice example. So it looks like these x minus 2's, these cancel, right? Anything else exactly the same? So it doesn't look like anything else is exactly the same. Now this problem's a little bit tricky because you have to recognize here this 4 minus x and this x minus 4. These two are almost the same. What's different is they're completely opposite signs. What that means is the 4 is positive here, the 4 is negative here, the x is negative here, the x is positive here. So when the signs are exactly the same, right? When they're exactly the opposite, right? What you want to do is you need to make them the same. So what you can do is you're going to factor out. If you factor out a negative 1, what happens is this will make this negative, this will make this positive. So the signs change, right? But you need to have this negative 1 out here. If you don't have the negative 1 out here and you just change the signs, that's wrong. So when the signs are completely opposite and you need to make them the same, what you're going to do is you're going to factor out a negative 1 to one of the terms. So I did it to this one. So now you notice these signs are the same. 4 is negative, 4 is negative, x is positive, x is positive. We have the negative 1 out here. So now it's okay to cancel these, but remember you have to have that negative 1 out here. So then our final answer would be negative 1, right? 7y minus 5. Then on the bottom we have the 5, and also the 3x plus 2. Now if you want, you could distribute the negative 1 and distribute the 5, it's really up to you, or you could keep it like this. Alright, if it's a multiple choice test, like on the state test or something, alright, let's say you have your answer like this, but you notice in the answer choices they distribute it, then just distribute it and then find the right answer. Okay? And then once again, if they ask you for restrictions, okay, now this one's going to be a little bit tricky, right? And let me explain why. So we're looking for restrictions, right? So we're going to find out what x cannot equal. So remember, we always start with our answer. So over here, like 5, we're not worried about that. Over here, 3x plus 2, right? So when is this going to be 0? Right? Now if this 3 was in here, it'd be real easy. You would just know that it's a negative 2. But since there's a 3 here, right, you have to remember, so what you're doing is you're just doing the opposite sign over here. So there's a negative 2, and then if there's a number in front of x, you have to divide by that number. So when x is negative 2/3, right, that'll make 0 here, which we can't have. Now the other thing that makes this problem tricky is, remember, we have to check the denominator, right, anywhere in the problem. So going over here, even though these cancel, you have to consider them. So this can't be 0. So when is this going to be 0? When x is 4. When is this going to be 0? When x is 2. Alright, this 3x plus 2, we already covered it with this right here. And then what also makes this tricky is, at the beginning of the problem, remember we had flipped Alright, remember we had flipped this to make it, to have it look like this, because we changed from division to multiplication. So over here we had the x minus 2 and the 7y minus 5. It used to be on the bottom, so you have to consider it for restrictions also. So x, when is this going to be 0? When x is 2. And then when is this going to be 0? When y, alright, so y cannot equal positive 5 over 7. So these are all your restrictions right here. Okay? So remember, anywhere in the denominator throughout the problem, alright, you have to search. You have to look at everything in the denominator when you're looking for restrictions, right, throughout the whole problem.